All right, so in this video, we're still continuing our rational applications unit, but in this unit, we're specifically referring to problems involving motion. So something's moving, obviously. Okay, so there's some things we need to keep in mind when we're solving problems involving motion. And it is that distance equals rate times time, which you already know. So let's say we're driving, we're going 10 miles an hour. Maybe we're in a golf cart. We're going 10 miles an hour, and we drive for 3 hours. Well, if we drive 10 miles per hour, and we drive for 3 miles, then I've traveled a total of 30 miles. Or 3 hours, I mean. We've gone 30 miles. So distance is rate times time, and we're going to need to keep that in the back of our mind for the majority of these problems. Okay, so let's start with this one. There's a chart that we're going to fill out for all of these, and then once we fill out the chart, it kind of sets itself up for us. So in this question, it's talking about a kayaker, and a kayaker traveled 5 miles upstream and then 8 miles downstream with an average current speed of 3 miles an hour. If the trip took 3.5 hours, what was the kayaker's average paddling speed? So, there's upstream and downstream. Here, let's use a darker color. There's upstream and downstream. And then we have distance information, rate information, and time information. So it says a kayaker traveled 5 miles upstream. So upstream, we traveled 5 miles. Downstream, we traveled 8 miles. It tells me that the current speed was 3 miles an hour, not current as in right now, current as in water flow. The current speed was 3 miles an hour. If the trip took 3.5 hours, what was the kayaker's average paddling speed? So time, it tells me it took 3.5 total hours. So that pertains to both. So it's kind of in both spots. So 3.5 total. And rate, we're trying to find their average speed. So their average speed is x. Because average, we're not saying upstream and downstream. We're saying the average including both things. So assuming they were always traveling the same speed. Now for this, we do have to have some knowledge of how nature works. So if you were paddling, if you're in a kayak and you were paddling upstream, you were going slower than your average speed because the current is slowing you down. If you're traveling downstream, you're going faster because the current is pushing you. It's helping you go forward. So if the current has a speed of 3, upstream, we are going our average speed minus 3 because the current is slowing us down. When we're going downstream, we have our average speed, but we're going faster than that because we have x plus 3. So I know this is maybe a little confusing for some of us, but current, if we're going upstream, we're slowing down or we're being slowed by the current at 3 miles an hour. When we're going downstream, the current is helping us. It's pushing us forward, so it's adding 3 to our speed if we're kayaking the same speed the whole time. All right, so now here's where we care about D equals RT. So, distance equals rate times time. Their time took a total of 3.5 hours. So the more important information for us is time equals distance divided by rate. So if time equals distance divided by rate, that means if I take the distance divided by rate of upstream and the distance divided by rate of downstream, that took me a total of 3.5 hours. So if I take my upstream information plus my downstream information, I know that it took me a total of 3.5 hours to complete the job, or to complete my kayak trip. So now we need to solve. So this is the setup, and this is our hardest application, but also kind of the most relevant. So here's our setup. So now we need to solve. So to solve this, I cannot cross multiply. So I need to find my least common denominator, and my least common denominator in this case is x minus 3, x plus 3, and the entire equation gets multiplied by my LCD. So the entire equation gets multiplied by my LCD. So that goes away, and I get 5x plus 15 plus 8x minus 24 equals 3.5 x squared minus 9. So here I get 13x minus 9 equals 3.5 x squared. And since I have a quadratic, I need everything on the same side as the quadratic. So I've kind of ran out of room here, but I'll go to the top. So I've got 3.5 x squared minus 13x minus 22.5 equals 0. If I quadratic formula this, which I'm not going to go through because this is already taking me 8 minutes, and we know how to use the quadratic formula. So if I use the quadratic formula here, I get a positive answer and a negative answer. Well, the negative answer, I can't paddle at a negative speed, so that doesn't make any sense. So I paddle an average speed of 5 miles per hour. Okay, so this one's a little more straightforward. It's talking about two guys running. So Terry can run 15 miles at the same time that it takes Mark to run 21 miles. If Mark runs 2 miles an hour faster than Terry, how much faster do each of them run? So again, I have my distance, my rate, my time. I've got two guys here. I've got Mark and I've got Terry. So Terry runs 15 miles. Mark runs 21 miles. Mark runs 2 miles an hour faster than Terry. So it doesn't matter what you choose here, but let's just say Mark runs X miles an hour. So you can make Terry run X, but let's just say Mark runs X miles an hour. That means if Mark is 2 miles an hour faster than Terry, then Terry is 2 miles an hour slower than Mark. So Mark would be X, because he's running X speed. Terry is Mark's speed minus 2. And then they both take the same time, so their times are equal. And just like the last one, the equation that we're keeping in mind is distance equals rate times time, but time is kind of more important. So time is distance divided by rate. So just like the last one, I'm going to take distance divided by rate, which is the important information. So Mark runs 21 miles at X speed. Terry runs 15 miles at X minus 2 speed. If the times are equal, then that means that we can set these equal to each other, because time equals distance divided by rate. So we can set the distance divided by rates of these two men equal to each other if they ran the same amount of time. So here, we can cross multiply. So we get 21x minus 42 equals 15x. And then we get negative 42 equals negative 6x. So x equals 7. So we've got two guys. We've got Mark and we've got Terry. So Mark runs X speed. So when we get X equals 7, that's Mark. Terry runs Mark speed minus 2. Oops. So Mark ran 7 miles an hour. Terry is Mark minus 2. So Terry is running 5 miles an hour. So the key to these is we need to set up our chart, fill in our chart in the bottom left corner of the screen, fill in your chart, and then almost always it's going to be time equals is the important information. So we're going to set distance and divide it by rate and go from there. All right. So here's our last one, I promise. I know this is going to be a long video, but hopefully it's helpful. So here, I'm going to make the chart while I read the question. So we've got Harriet drove for 90 miles in slow traffic on a 2-lane road before getting on the tollway. When she got on the tollway, she increased her speed by 20 miles an hour and drove for 130 miles. If she drove for a total of 4 miles, how fast was she driving on the tollway? Hopefully within the legal limit. Okay, so we've got 2-lane road. So we're sitting here driving on 377. And then we get on President George Bush Express on the tollway. So we have distance, rate, and time. So Harriet on our 2-lane road drove 90 miles. On the tollway, she drove 130 miles. It says on the tollway, she increased her speed by 20 miles. So let's just say that X is her speed on the 2-lane road. If X is her speed on the 2-lane road, then on the tollway, she was going X plus 20 miles an hour because she increased her speed by 20 on the tollway. So if she was driving X speed on the 2-lane and she increased her speed of X by 20, her rate on the tollway is her 2-lane speed plus 20. Time, it says we drove for a total of 4 hours. So she's got a long commute. But we drove for a total of 2 hours. So just on the last, we've done this 3 times now. But T is really the most important. So T equals distance divided by rate. So if we take the 2-lane information, so distance of 90 miles divided by a rate of X plus the tollway information, 130 miles over rate plus 20, it equals our total time. And our total time here was 4. So just like on the first example, we cannot cross multiply here. So we've got to find our LCD. And my LCD here, my LCD is x and x plus 20. It's both things. So x and x plus 20 are going to go on top of every fraction. So that cancels, that cancels. So we have 90x plus 1800 plus 130x equals 4x squared plus 80x. So now we have to combine like terms. So we've got 220x plus 1800 equals 4x squared plus 80x. We've got to move this stuff over. And I've ran out of room, so I've got to go to the top. So I'm up at the top, and then if we just go ahead and quadratic formula this equation, or factor it, whatever you want. So I'm just going to use the quadratic formula because these numbers are huge. So if I use the quadratic formula, I find that x equals 45 miles an hour. And if we remember, we've got a 2-lane road and a tollway. And back in my original equation, I said that x stood for the 2-lane road. So when I got x of 45, we drove 45, kind of out of room, but 45 miles an hour on the 2-lane road. And if we drove 45 miles on the 2-lane road, we drove 20 miles an hour faster on the tollway. So that means on the tollway, we went 65 miles an hour. And the question says, if she drove for a total of 4 hours, how fast was she driving on the tollway? So the tollway, she was driving 65 miles an hour. So I know these problems are long, but we can do it.